From our previous lecture, we know what is work and what is positive and negative work. Now, we'll further discuss some points about works. So, first of all, we'll discuss the gravitational work. It is known as gravitational work. So, what is gravitational work? Suppose there is a object at height h. Suppose there is an object h at height h. So, if this object fall down from this height, so it will do some work, so how we can measure the work for this object from height h? This is simple. We know the formula of work is work w equals to f into s, f dot s. Here s means the displacement, and in that case of free fall, the s means our height h, and force is something that occurs due to the gravitational force. So for that we know gravitational force f of g equals to w, or you can say the weight, and weight w equals to m of g. So instead of f we can use m of g. So the whole equation for gravitational work w equals to mgh. Now suppose this is an inclined path, and an object wants to come from this path to this point, point A to point B. So the distance from the distance from ground to point A, or the height, is equals to h, and x is the path the body is traveled. X is the path this body is traveled. We don't consider the x, the body, the travel path. We only consider the height from the ground. So only we will not take the value x. Instead of, we will take the value of h for measurement. Suppose now a suppose the body is moving from point A to point, suppose this is point D. So this distance AD equals to, suppose we take this as S. Now we have to consider what will be the work done for this object coming from the height from the point A to point D. Suppose this is an angle of alpha. This is the angle of alpha between the inclined path and the horizontal line. Now we have to find out the work done for this object from point A to point D. So how we can find these things? We know the weight W is what at the downwards. So this is the mg, or the weight is working downwards, and for that there is for this there is two component of mg. One is horizontal component and another is uh, vertical component, and as this is alpha, this will also be alpha, and this is our horizontal component mg cos of alpha, and this is our vertical component, which is known as mg sin alpha. And we know for mg sin alpha, it actually moves in the inclined path. So for that we know our force is mg, and our h is the distance. Here the distance is s. So for this kind of scenario, if I want to find out the work, so the work w will be mg s sine of alpha. Okay, here sine alpha means this alpha, sine alpha. So this is the whole concept of gravitational work. Oh, another thing I just forget, that the unit of the work is joule. We represent the unit of work is as joule, and this is, we have to remember that if I use work, we will use unit as joule. So this is about work, gravitational work. Now coming to the next part, we will discuss work done by variable force. So now we will discuss work done by variable force. So what is this? Suppose I draw a graph about here. It's here it works as in y-axis we represent this as force, and x-axis we represent the displacement x. If if our force is variable, like it doesn't constant. So for variable force, suppose this is a force function for that for some kind of for I implying uh, I act some force on some body, and who the force is look like that curve. Okay, so for this kind of scenario, how we can measure our work, as the force is all time changing. For that, we will use the concept of integration. So what we will do? We take this part. So this is will be our x naught point, and we will take this part. This will be our x1 point. So if I divide this thing in some small pieces, and if I want to find out this area, that will be something like that. Oh, sorry. So if I take this part, that will look like a rectangle. That will look like a rectangle. So if I find out this portion of rectangle, the area of this portion of rectangle, and then if I find out the suppose this is I divide this whole path with n times, and n is the step size. So if I there is an area of this kind of rectangle, then if I join all the area, or if I sum all the area, that I will get the whole area from x naught to x1, and this is known as 1. So this is the concept of actually what I tell is the concept of integration. And for variable work, we will use the we will use the concept of integration. Suppose for this small part, we find out this small part work. We represent this small part work as dw, and this dw is equals to f of x into dx means this distance is known as d of x, and f of x is our this curvature function. Okay, so this is known as so this is the formula. We find out this portion, like this area of that curve. Now we have to find out the whole area of that curve, and we have to find out from the x naught to x1, so for that we will use integration formula. So how we use integration formula? We use this sign. This is known as integrate sign, and we have to give us limits. So here our limit is x naught to x1. So this is from, if we find out the whole area of from x naught to x1, we will get the whole work. Whole work means the work done by done from x naught to x1 point. So this is our total work w. So our total work w equals to x naught to x1 fx into dx. This is the concept. What I tell, this is the concept of for finding out work done by variable force. Now let us take an example to understand it greatly. So suppose you have to find out an example. Work done by work done in expanding a spring. So how spring do work, or how work is generated in spring, we will discuss this thing. Suppose this give me some time to draw this figure. Suppose this is our spring, and we add some weight at the end of the spring, and one end is connected to a rigid body. Okay, so this is our rigid part, which is connected to a rigid part, and we uh, add some weight in the end part of our spring. So now if we pull down the spring, if we pull the spring, okay, if we pull the spring and move it from this point to this point. So as this is the distance, this distance is x, this distance is x, we pull the weighted part of the spring from x distance. So how the work is done in that body, we have to find out. So for that we have to know an important features of spring. So this features is known as uh, if x, here our x be the extension of length, is there if our x is the extension of length of the spring, and due to the application of horizontal force, we applied some horizontal force F in that direction. Due to this action, a restoring force Kx will be developed. We know if we pulled a spring, the spring tends to come to its original size or original shape. Why this is happening? Because there is a restoring force. Force. Restoring force to to come back our spring in his original shape. So for restoring force, we know restoring force F is proportional to, if we represent this as restoring force, Fs is proportional to minus of x. Fs is proportional to minus of s. No, sorry for my mistake. What is restoring force? F is proportional to x, and for horizontal force, that this force applied, as we applied this force, for this force f of s, our is proportional to minus of x. We have to remember this thing. Here fs is horizontal force, here fs is horizontal force, and our f is restoring force, and we have to find out the work done for this horizontal force fs. Sorry, we have to find out the restoring force, work done for the restoring force F. Okay, and we know there is for to remove this proportional change, we use a constant that is known as spring constant K. Spring constant K. So we can write F equals to Kx. Okay, if I write that, so we can write F equals to Kx, or Fs equals to minus of Ks. Okay, so this is the main concept of spring. Now we have to find out the work done for when we pull down a string from that point to that point, and what work done is expanding a spring for the restoring force. Here we find out the work done for by restoring force. So we know, to find out this work, we will integrate the whole part. So here to find out the whole part, we will use, as suppose this is our equilibrium point, x naught equals to 0, and this is our expanding point, x1 equals to x. So we have to find out from x naught to x1 and f of x into dx. F of x into dx, and here our f of x means kx. Here our f of x means kx. So we can write instead of x naught we will use 0, as it is equilibrium point, and instead of x1 we will use x, because we pull down from equilibrium point x naught to x point, and our f of x equals to kx. So if we have calculate the whole scenario, we will get, by implementing the formula of integration, we will get half of k x square. So this is the work done in expanding a spring because of restoring force. So this is the whole idea of restoring force, and work done by variable forces. So this is the whole concept. I hope you understand this whole concept, and gain and and gain knowledge about gravitational work and work done in expanding spring and the concept of work done for by variable force. So that's all for today's video. I hope you like this video. Do subscribe to our channel and like this video. Thank you.